This is Jesse and Matthew's algebra video. Our topic is transformations, and we will be more specifically analyzing how the parent functions of y equals x squared, y equals absolute value of x, and y equals square root of x are affected by translations, reflections, and dilations. First, our translations. We can see in this graph that adding 3 to y equals x squared translates the parabola up 3 units. We can also see that subtracting 3 from x within parentheses translate that parabola left 3 units. This demonstrates how important parentheses are when observing how functions are changed. Okay, so this is basically how it works on a calculator. You have your parent function x squared, and then you have the transformation x squared plus 3. So this is going to translate it up 3 units. Yep. Next, we are looking at reflections, which are similar to translations in that parenthesis placement affects the reflection. When you change y equals square root of x to y equals negative square root of x, it reflects the line across the x-axis. And when you place the negative inside of square root of x, it reflects across the y-axis. Okay. Alright, so, and this is how a reflection works on a calculator. You have your parent function, y equals square root of x, and then this is the reflection, negative square root of x, which reflects it across the x-axis. Lastly are dilations, which are multipliers which determine the slope of the line. And you can see that y equals 2 absolute value of x makes the slope a lot steeper as compared to y equals absolute value of x. And when you multiply it by 0.5, it makes the slope a lot wider in comparison to the parent function. So this is how dilations work on a calculator. We have our parent function, y equals absolute value of x, and then we have our dilation, which is y equals abs of x times 2, and that makes the slope a lot steeper. Okay, so why are transformations important? Transformations are actually used a lot in the real world beyond just math class. Transformations are used in the fields of publishing, computer software, construction, machinery, statistics, and chemistry, or a lot of different sciences. You know, a lot of people would have to use them anytime they're trying to compare different sets of data or to see how different kinds of equations interact with each other. And this project has really bettered my understanding of transformations, because I can now identify them by looking at equations and see how they will affect the graphs of those equations.